So let's talk a little bit about namespaces. So ensuring the uniqueness of names is one of the challenges of any C or C++ programmer. It's a rule you learned early in C, right? No two variables can have the same name. No two functions can have the same name. And you can imagine that, if you're writing a fairly small program that fits all in one file, it's really not that hard to guarantee that names are unique, right? Variables within a single function scope, it's easy to know that you haven't reused a variable name, though sometimes we do make that mistake. And even like within a single file, you can just search that file to see, oh, have I used this name before? And you can avoid name collisions on classes or functions or global variables. Okay, but imagine you're writing a very large program with hundreds or thousands of files implemented by many different programmers over many years. Now that's the state of the art. When you go look at an operating system or a large application, that's the scenario. And what that means is it's impossible to know all the variable names in active use in that program. And so languages kind of realized, programmers realized that the C language didn't help them enough in this regard. And so C++ introduces the idea of namespaces to make it possible to ensure the uniqueness of names. And I'm just kind of repeating myself now, but right, some names turn out to be common. Things like counter or print or debug. Programmers are just going to reach for these common names a lot of times. And if you find yourself in a situation where you've named a variable the same thing as another programmer, you have no choice but to change it or to change them both. And this gets quite tedious, especially in code that you yourself did not write. And sometimes you can't change that other code at all. C++ namespaces come to the rescue for these and similar kinds of problems. Okay, rather than needing to give every single variable or class a unique name, what we do instead is we simply need to place them in a unique namespace name. And so a namespace just creates a set of things that are grouped together under a common label. One namespace you've already heard about is the standard namespace std. And for anything part of the C++ standard library, any function or class, it's generally placed in that namespace to guarantee that it won't have a name collision with something in the program that, it's something in the programs that, any individual programmer writes. So it looks something like this over here on the right side of the screen. So we have the namespace keyword, and then any name we want. Some useful name would be an example, and then an open brace, and then eventually a closed brace. And then within those braces, you place all your variables or classes or functions that you want to declare as belonging to that namespace. Okay, and then outside of that namespace, to refer to something that's inside the namespace, you have to prefix name with the namespace ID. So for example, to refer to variable X that's declared as part of the namespace, then we have to say some useful name : X. And then that refers to the variable that we put in this namespace. All right, a neat thing about namespaces, like almost any other thing in C++, is they're open. What that means is that I can start a namespace in one file and I can finish it in another file as long as the two braced regions have the same namespace identifier. They're part of the same namespace and they're allowed to share a namespace ID. So I don't have to cram everything in a namespace into one file. I can spread them across multiple files. That's fine. The only requirement is that things belonging to the same namespace are declared with the same namespace identifier. Okay, so to reference a declaration in another namespace, we have to provide a namespace qualified identifier. This is like what I was showing you before. So you have the namespace ID followed by followed by the specific variable or function you want to use. And these two colons are simply an operator that resolves the scope, that says, okay, I, I mean, actually, you can kind of like a scope resolver, but what it's really doing is just creating a break between the two different identifiers, right? Well, we couldn't just stick the X on the end because confused and think that some useful name X was itself an identifier, which wouldn't be right. And so those two colons just separate the namespace ID from the variable name that we want. Now, we all know about global variables in the C language. C++ also has global variables. And so I could declare some variable like A that's not inside any namespace. And then I could declare another variable A that is inside a namespace. Well, how do I get at this A that's not in a namespace? Also, I could declare a local variable A that that has the same name as this global A and this A inside this name. Fortunately, C++ gives us a way to differentiate all these different variables named A. So within the main function, if I want to refer to the global A and not the local A, I can simply prefix A with two colons. And what this means is that this is a global variable that's not a part of any namespace. It looks weird because there's nothing to its left. But this just means A is a global, not part of any namespace. Whereas if I say capital A colon A, that means this is a global variable that's part of the namespace A. Okay, and then if I were to just refer to the variable A with no colons, then that would be the local variable A. So down here in my printf, I print the address for each of these variables to prove that they're different variables occupying different places in memory. And so ampersand A would just be the local variable A, ampersand colon A would be the address of the variable A, the global variable that's not in any namespace, and then ampersand A colon A would be variable A that's inside namespace A. And if you, and I encourage you to take this program, compile it, and run it, and what you'll see is that each one of these variables are given a unique address in memory. Now, what you're going to see a lot in code in the book and in other resources you look at online, you're going to see this statement at the top of a lot of C++ programs using namespace standard. Okay, and this is an example of the using directive. Now, when you place things in a namespace and you want to reference them, you always have to, append the name with the namespace. And this gets annoying and tedious. If you're always appending the same namespace name to everything, it just clutters up the code a lot. And so that we can avoid doing that, this using namespace directive allows us to drop a common namespace. And the compiler will check that namespace anytime it sees an identifier it doesn't recognize. So for example, in this program over here to the right, I'm using cout. And we know that cout is in the standard namespace. But since I said I'm using namespace standard in my program, then the compiler knows that anytime it sees an identifier, like cout in this case, since there's no local variable named cout, it's going to have to go check for a global named cout. And because we said we're using standard, it will go check the standard namespace and see if it's inside that namespace. And sure enough, it's going to find it, and it's going to allow this code to proceed. And this allows us to drop standard from any name that's part of standard, in the code that follows. Now, this using namespace standard only applies within this one file. So if you have another file, you would have to insert using namespace standard again at the top of that file to get those same benefits. Likewise, it only applies to the code that comes after this directive. So any code before the directive would need the standard identifier, but any code after it could drop it. Right, so the most common namespace we're going to use is the standard namespace. Most of the C++ library is declared in that namespace, so we're often going to put this using namespace standard directive at the top of our programs. Okay, so in summary, namespaces help us ensure that all names are unique. Libraries like the standard library for C++ usually wrap all of their functions and classes within that namespace to ensure that they're unique and have a different name from anything you would put in your own program. Okay, declarations within a namespace must be prefixed by the namespace identifier. For example, if we want to refer to cout, then we need to say it's in the standard namespace by prefixing it with the std : notation. Okay, however, if we don't want to do that on all of our all the variables or methods we're using in standard, then we can use the using directive to indicate which namespaces we're pulling global variables from, and then drop the namespace identifier so that we can shorten our code.